All right, so this is Chapter 12, Section 3, Determinants and Inverses. Our learning objective is to find the inverse of a matrix. And just so you have it in your vocabulary repertoire, a square matrix is a matrix with the same number of rows and columns. One of our key concepts is the identity and multiplicative inverse matrices. For an n by n matrix, the multiplicative identity matrix is an n by n matrix, and it has ones along the main diagonal and zeros elsewhere. So for a 2 by 2 matrix, the identity matrix is 1, 0, 0, 1. For a 3 by 3 matrix, the identity matrix is 1, 0, 0, 0, 1, 0, and 0, 0, 1. If A and B are square matrices, then A times B is equal to B times A, which is equal to the identity. Then B is the multiplicative inverse of A, written as A to the negative 1. Now this isn't truly to the negative 1 power. It's read as inverse of A. All right, so to determine whether matrices are inverses, all we have to do is multiply them and see if we get ones along the diagonal. So I'm going to show you, in this example, they put these matrices in a graphing calculator, and you can see that the result is the identity matrix. So since A times B is the identity and B times A is the identity, then A and B are inverses. So you put them in both ways, and if they come out inverses, then you know you've got it. All right, so we're going to do that for these two matrices in number 1. And just to show you how you can use, if you don't have a graphing calculator, it doesn't matter, because you can use the online graphing calculator. This is matrix.reshish.com/multiplication. So we have a 2 by 2 matrix and a 2 by 2 matrix. So matrix A dimension is 2 by 2, matrix B dimension is 2 by 2, and then I'm going to set the matrices. So I'm going to put my first matrix in here, 1, 1, 5, 4, and the second one here, negative 4, 1, 5, negative 1. And then I'm going to calculate. Boop. And when I do, I get my matrix is 1, 0, and 0, 1. So that checks out for A times B. Now I have to check it for B times A. So pull up. All right, so let's put these in again, but I'm going to put B in first. And then A. 5 and 4, and calculate. And once again, I get the identity. So because when I multiply these two items together and I get the identity both times, then A and B are inverses. Look at the reasoning. Does the matrix 0, 0, 0, 0 have an inverse? Explain. since there is nothing you can multiply 0 by to get a 1, it does not have an inverse. All right, every square matrix with real number elements has a number associated with it. That number is called the determinant. And if A, we're going to look at A and number its, or letter its elements as A, B, C, and D. Then the determinant of A is A times D minus B times C. And I like it because it's really similar to what we do by cross multiplying it. Okay, so the determinant of a 2 by 2 matrix is A times D minus B times C. The determinant of a 3 by 3 matrix is A1, B2, C3, boop, plus B1, C2, A3, boop, plus C1, A2, B3, boop, minus A3, B2, C1, plus B3, C2, A1, plus C3, A2, B1. Let me erase all that so you can kind of see. So you rewrite the first 2 columns right next to your 3 by 3, and you go down, 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 equals, minus what you get when you go up, up, up. Boom. The area of a triangle, just so that you guys know, has a little formula that's dependent upon matrix. If you take one, so if you have a triangle and it's got 3 vertices, because that wouldn't be a triangle without it, you put the first set of vertices in the top row and then a 1, second set of vertices in the second row and then a 1, third set of vertices in the third row and then a 1. When you do that, you find half of the determinant, you can find the area of that triangle. So let's do that together. All right, so let's make a nice little matrix here. We're going to take the first 2 items, put them in, put a 1, second 2, and put a 1, third 2 items, and put a 1. We want to rewrite the first columns here. And then we are going to, if we look at the pattern, we're going to go down first. So we're going to start in the top right corner and go 1 times 0 times 1 plus 3 times 1 times 5 plus 1 times -3 times 0. And then we're going to reverse the direction. And we're going to go up, starting from this corner. 5 times 0 times 1. 0 times 1 times 1. And then 1 times -3 times 3. All right, so this is 0 plus 15 plus 0. And 0 plus 0 plus -9. That's 15 minus -9. So this is, the determinant, so if this is A, determinant of A is equal to that. 15 plus 9 is 24, and then the area of the triangle is equal to half the determinant of A. That's half of 24. And that's 12. 12 units. All right. So now that we have that, all that information, we are going to find the inverse of a 2 by 2 matrix. All you have to know is to find an inverse of a 2 by 2 matrix. You find the determinant and put it over 1, and then you mix up the elements of the matrix. So instead of A, you put D. So you switch these two, A and D, and you leave B and C where they are, but you make them negative. So we are going to find the determinant of a matrix. So here it is. If I have, this is A, B, C, and D. So the determinant of A is A times D, which is negative 3 times 3 minus 6 times negative 1, and that is negative 3. He goes 1 over the determinant here, and then I shift around, so I switch A and D. So instead of negative 3 and 3, I have 3 and negative 3. And then I want to change the signs of negative 1 and 6. So I have, instead of negative 1, I have 1. Instead of 6, I have negative 6. And then you multiply this through, and voila, you have the determinant. Now, we could use a calculator to check that you have found the true inverse. So when we go here, I have a 2 by 2, and my first one is negative 3, 6, negative 1, 3, and then my inverse was negative 1, 2, negative 1/3, 1. Calculate, and I should get the identity matrix, and I do, yay! Because an inverse is, when an inverse is multiplied by its buddy, it gets to have the identity. Okay, so does the matrix have an inverse? If so, what is it? So we're going to find, the first thing we do is find the determinant of A, and that's 4 times 2 minus 3 times 2, which is 8 minus 6, which is 2. So with the determinant being A, or the determinant being 2, yes, it has an inverse. And to calculate that, we go 1 over the determinant times, we're going to switch A and B, so, or sorry, A and D, 2 and 4, and then we're going to leave these guys in place, but change their sign, and then everybody's going to get this 1/2. It's going to be great. So 1/2 times 2 is 1. Negative 2 times 1/2 is negative 1. Negative 3 times 1/2 is negative 3/2. Also can be written as negative 1.5. And then 4 times 1/2 is 2. So this is the inverse of A. And that is how that goes. If the determinant were equal to 0, we would not have an inverse, because I cannot put 1 over 0. It would make this part impossible, this part. So if it's 0, it doesn't have an inverse.